Here we have a SAT math problem. Okay, let's go with the question. F of x equals to a to the x to the power negative b. The exponential function given above passes through the point c, 8 and 2c, 350. What is the possible value of b? Okay, in the given function, we have to find a possible value of b. In the given function, usually this f of x represents y. So we can replace this f of x by y. Then we get y equals to a to the x to the power negative b. Since the graph of the given function passes through the point c, 8, we can plug in the x coordinate c for x over here and y coordinate 8 for y over here. Then I'm getting 8 equals to a to the power c negative b. Let me consider this is equation number 1. And also the graph of the given function passes through this point as well. Also, that is 2c, 350. So we can plug in this x coordinate 2c for x over here and 350 y coordinate for y over here. Then I'm getting 350 equals to a to the power of 2c negative b. Let me consider this is equation number 2. Okay, now I'm going to subtract the first equation from the second equation to eliminate b. Let me do it. That is equation number 2 negative equation number 1. Okay, first let me write the second equation, that is 350 equals to a to the power of 2c negative b. Okay, here we have negative sign in front of the first equation. That is, we have to multiply each term on both sides of the first equation by negative sign. When I multiply this 8 by negative sign, I am getting negative 8. And when I multiply this a to the sixth power by negative sign, I am getting negative a to the sixth power. When I multiply this negative b by negative sign, I am getting positive b. So here I will be able to eliminate b. That is, negative b, positive b will cancel out. So when I combine this positive 350 and negative 8, I am getting positive 342. On the right side, we have a to the power of 2c negative a to the power of c. 342 equals to, so here we can write this a to the power of 2c as a to the power of c whole square negative a to the power of c. Because here we have base a and we have exponent c, and for this complete stuff again we have exponent 2. Whenever we have two exponents like this, what we can do is we can multiply the two exponents 2 and c. So this is equivalent to this stuff. Okay, now what I'm going to do is I'm going to substitute a new variable for this a to the power of c. So to make the solving process easier, okay, let me assign a new variable k for this a to the power of c. Then we get 342 equals to, for this a to the power of c, we can plug in the new variable k. Then we get k square, because we have exponent 2 for a to the power of c negative. For this a to the power of c also, we can substitute the new variable k. Okay, here we have a quadratic equation. Now, to solve for k in this quadratic equation, we have to get it in standard form. That is, we must have all the terms on one side of the equation, on the other side we must have 0. Okay, now let me get up this 342 on the left side. For that, we have to subtract 342 from both sides. Let me do it. Then this positive value and negative value will cancel out. I'm getting 0 on the left side, k square negative k negative 342 on the right side. Okay, now let's try to solve this quadratic equation by factoring. Since it's a digital SAT, like if you want, we can solve it using Desmos. Now I'm going to solve this one by factoring. For that, we have to multiply the constant of negative 342 by the coefficient of k square. In this case, it's just 1. So when I multiply this constant by 1, I'm getting negative 342. Now I have to get two factors over here, so that the product of the two factors equals to negative 342, and the sum of the two factors equals to the coefficient of k. That is, in this case, it's negative 1. Okay, so I think negative 19 and positive 18 will work. When I multiply negative 19 and positive 18, I'm getting negative 342. When I add them, I'm getting negative 1. That's the coefficient of k in the quadratic equation over here. Further, I have to divide these two factors by the coefficient of k square, that is 1. Okay, let me divide both these factors by 1. Even when I divide them by 1, still I'm getting a negative 19, positive 18. Usually when we solve a quadratic equation, we'll be getting two values for the variable. So here we have k, so we'll be getting two values for k when we solve this quadratic equation. Now to get the first value of k, I have to change the sign of the first factor over here. It's a negative. When I change the sign, I'm getting positive 19. That's the first value of k. Now to get the second value of k, I have to change the sign of the second factor. It's already positive. So when I change the sign, it will become negative, that is negative 18. Actually, k is a variable taken by us. Now it has to be replaced by the original stuff, that is a to the c power. Then we get a to the power of c equals to 19. And here when I plug in a to the c power for k, then I'm getting a to the power c equals to negative 18. Okay, now I got two values for a to the power of c, that is 19 and negative 18. So now we can plug in these two values for a to the power of c either into the first equation or into the second equation to solve for b. Okay, now let me erase the stuff and continue the problem. Okay, now we have to plug in these two values of a to the power of c into one of these two equations over here. Let me use the first equation, because if I want to use the second equation, I have to write this a to the power of 2c as a to the power of c the whole square. Then when I plug in 19 for this one, it has to be squared. So it will take some additional work. Better we can use the first equation. It will be easier for us. So when I plug in this 19 and negative 18 for a to the power of c, you'll be able to solve for b, because our aim is to find a possible value of b. Okay, first let me plug in this 19 for a to the power of c into the first equation. Then I'm getting 8 equals to 19 negative b. Okay, now my aim is to solve for b. Let me subtract 19 from both sides. When I subtract 19 from both sides, there's positive 19, negative 19 will cancel out. So when I combine this 8 and negative 19, I am getting negative 11 equals to negative b. So since our aim is to solve for b, we have to make this negative b as positive b. For that, we have to multiply both sides of this equation by negative 1. When I multiply this negative 11 by negative 1, I am getting positive 11. When I multiply this negative b by negative 1, I am getting positive b. Okay, I got the value of b, that is 11. Anyways, let's plug in the second value of a to the power of c, that is negative 18, in the same first equation over here. Let me do it. Then I'm getting 8 equals to negative 18 negative b. Let me add 18 to both sides. When I add 18 to both sides, this negative 18 positive 18 will cancel out. When I combine positive 8 and positive 18, I'm getting positive 26 equals to negative b. Okay, now to make this negative b as positive b, we have to multiply both sides of this equation by negative 1. In that case, I'm getting negative 26 equals to positive b. Okay, so your possible value of b is 11 or negative 26.